In this video lecture, we are going to use an example to understand the advantage of packet switching over circuit switching. The main advantage is that you are able to support more users or get more data through the network when you use packet switching. The example scenario will talk about let's assume a 1 megabits per second link that's being shared by multiple users. So in this diagram, this represents the 1 megabits per second, and there are n users that are going to use this link to communicate to the outside world. And if you assume that each users use about 100 kilobits per second when they are active, when they are sending data, they will use 100 kilobits per second, and only 10% of the time they are active. So at any given time, there is a 10% chance that this user is actually sending data, and at any given time, there is 10% chance that this user is sending data, and every other user it's the same 10% chance. So if we have a scenario like this, in this scenario, if we use circuit switching, because in circuit switching we have to reserve, you are going to be able to support 1 megabits per second. 1 megabits over 100 kilobits is the number of users you will be able to support, which is basically 10 users. So you can only support 10 users when you use circuit switching. Instead, if you use packet switching, since there is no resource reservation here, the users will use the link whenever they have data to send, and if they don't have any data to send, somebody else could use the link, so you're not holding on to the resource. You can actually demonstrate that you could support up to 35 users with the probability that more than 10 active users will be like less than 0.0004. So what this means is even if you allow 35 users to be connected on this link here instead of 10, you are still going to be okay more than 99.99% of the time, and only a small percentage of the time you will have collision between users and using the channel. So I haven't explained how we came up with the 0.004 number yet, but for this particular argument right now, just believe that number, and once you accept that number, you basically can see that with packet switching we could support 35 users majority of the time with a given 1 megabits per second link. So once we understand that that is the usefulness of packet switching over circuit switching, let's talk a little bit about how this number 0.004 is derived. In order to understand the derivation of that number, we need to know this mathematical formula called binomial distribution. This is something which you learn in probability theory. Some of its components you may learn in discrete math, but you need to have an understanding of probability. But even if you don't have a background in probability, the main components to understand here are, there are three entities here. There is this expression, and there is this expression. If you understand what each of them stands for, you would get a sense of how we are coming about with the 0.004 number. So the n combination k basically represents how many different ways can we. So in this example, n is 35 and k is 10, right? So the n combination k tells us how many different ways can you choose 10 users out of the 35 users that are using the link. And p, the small p raised to the k, represents the probability that those 10 users are active. So the small p here is the 10% number which we talked about as the uh, active time for every user, and p raised to the k tells you what is the probability that 10 of them will be active, and 1 minus p raised to the n minus k tells you what is the probability that n minus k of the users are not active. So if you take this expression, what we are calculating basically is how many different ways can I choose 10 users out of 35 users, times what is the probability that those 10 users will be active, times what is the probability that the rest of them will not be active. If you multiply these three entities, you calculate the probability that only 10 users will be active at any given time, and that, if you plug in the numbers, you will get the result 0.004. That's how we come up with this result.